In this video we'll walk through the algebra test solutions. So let's get stuck into it. So the first question was simplifying using addition or subtraction. So the rule is that you can only add together or subtract from each other like terms. So this is 8 lots of m and we want to remove 2 lots of m, so the answer is 6 lots of m. This one here, what we're doing is we're adding 3 lots of y to 4. They're unlike terms, so we can't stick them together, but we want to add y, okay? And so what we can do is add this y to the 3y to say that that's 4 lots of y in total plus 4. But that is not equal to 8y, which many of you went on to add 4 to 4y. We can't do that unless it's 4y itself. So our answer is 4y plus 4. Okay, this question here. So what we'll do with this one is identify the like terms. So this term here is like with this one here. So another way of thinking about this is 14xy remove 12yx. All right, so that's going to give us 2xy, or yx if you'd like, plus 3x plus y. And because they're unlike, or all three of those terms are unlike, we can't stick any of them together, so that's our best answer. This one here, we've got 7 lots of x squared plus x. Now, x and x are the same variable, but this variable is being squared and this variable isn't, so we're not allowed to stick them together. But I can put that 5x squared onto the 7x squared to give us 12x squared plus x, and again, that's our best answer. Okay, when we write things with, in algebra, we don't usually write the multiply signs. So we're going to write 7 times 5, which is 35, times x is just 35x. This is 5 lots of 3a, which is 15a. So 5 lots of 3 with an a on the end. This one here is worth 2 marks, so you need to have a method mark here. So we're going to do this multiply first and this multiply second. So it's 3 lots of 4m, which is 12m, take away 2m times 5 is 10m. 2m take away 10m is 2m. This one here might be best to see this as a fraction. 4a divided by 2 is 4a over 2. Then we're going to think what goes into 2 and that also goes into 4. The answer is 2. So 2 goes into 2 once, 2 goes into 4 2 times, leaving us with 2a. This one here we'll do in a similar way. What we can see is 4 will go into itself and 4 will go into 12. So we'll say that 4 goes into itself once and 4 goes into 12 3 times. So the answer is 1 over 3y. Many of you who use cancellation just cancelled that off and assumed it disappeared completely and wrote the answer as 3y. It needed to be 1 on 3y. Okay, question 3 looked at the fill in the box with the missing term to make the statement true. So this is the same as this. For them to be the same, I can see that something was added on to 3VW to make it 5VW. It must have been 2VW. This one here, 3a squared was multiplied by something to give us 15a squared b. So I can see here that the 3 was multiplied by 5, and this term here was multiplied by b to get it to look like 5a squared b. Evaluate each expression by substituting x equals 8. So what I'm going to do is where I see an x, I'm going to replace it with, no equal signs there, 8 plus 1000 equals 1008. This one here, before I substitute, I'm going to write that in expanded form. Now what we'll do is substitute 8 in. And now we'll just use order of operations to evaluate. 3 8s at 24. 24 plus 4 is 28. 2 lots of 28s is 56. 56 plus 6 is 62. All right, the multiple choice. If the expression m plus n is evaluated when m equals 4 and n equals 7, it is equal to. So that's just 4 plus 7 equals 11. For the expression 6a plus 2b plus 5, the value of the coefficient of b, that's the number before the letter, is 2. Consider the following 4 expressions. How many of the expressions contain a constant of 5? So this one does. There it is there. This one has a coefficient of 5 but no constant of 5. This is 5 itself, so this is always 5, so it has a constant of 5, so this is included. So we've got 1, 2 so far, and this 5 is first. The constant is last there, it can also be first, so this is also a constant, so that's 3. The expression that represents double the sum of m and p would be, so when m is doubled, it is 2m, and when p is doubled, it's 2p, and these are being added together. The only thing is that one is not in the list of possibilities, so what would be also the case is the sum of m plus p is multiplied by 2, and there it is there. So it depends on the form that you write it. This is a similar question. 7 is subtracted from a number d, and the result is multiplied by 3. So 7 is subtracted from a number d, and the result is multiplied by 3. Now that isn't anywhere here, and what you needed to do is use the distributive law here. So 3 times d is 3d. The subtraction sign, 3 times 7 is 21. It was E. X plus 7 is a multiple of 7. Which one of the following is also a multiple of 7? Or if x is a multiple of 7. Okay, so what are the multiples of 7? 7, 14, 21, 28, etc., etc. So x could equal any of these values. All right, so let's just see that whether A is the case. So if x is equal to 4, 7 plus 4 is 11, which is not a multiple of 4, so that can't be right. Now let's go to what is the correct answer. So C is the correct answer, and I'll show you why. It's because no matter what, we take the multiple of 7, which is 3 times whatever it is, which will always still be a multiple of 7. So whatever you choose, so just say it's 7, 3 times 7 is 21, and then we always add a number onto the end of what will be a multiple of 7, which is also a multiple of 7. So this one here will always be a multiple of 7. You could try that out by process of elimination by basically proving all other 4 wrong. Okay, section C, we've got Ms. Lowinger books a motorboat to drive around Lake Petoby in Warrnambool. The fee from Petoby boats was $15 per hour plus an additional booking fee of $10. If a boat was booked for 3 hours, show that the total hire cost is $55. So I'm giving you the answer, you've just got to show the calculation that would be used. So here I would do 3 lots of 15 plus 10 equals $55. So any calculation that showed that was the case is fine. Ms. Lowinger writes the following expression for the cost of hiring a motorboat. 15n plus 10, where n is the number of hours the boat's hired for. How much will it cost to hire the boat for 1.5 hours? So 15 times 1.5 plus 10. So what's 15 times 1.5? So it's 22.5 plus 10, 32.5, therefore $32.50. Ms. Lounger's husband finds another operator called Dodgy Don who hires motorboats according to this expression. So complete the following table that represents the cost of hiring a boat from Petoby Boats and Dodgy Don for 1 hour, 2 hours and 3 hours. So let's go 1 hour, substitute in there. 15 times 1 is 15, plus 10 is 25. 22, 25. 1 goes into Dodgy Don, and it's 20 times 1, which is 20. So Dodgy Don is actually cheaper, not so dodgy. 2 times 15 is 30. 30 plus 10 is 40. 2 times 20 is 40. Oh, they're the same. 3 times 15 is 45. 45 plus 10 is 55. That was also given to you in a previous question. 3 times 20 is 60. Dodgy Don's more expensive. After how many hours will the cost be the same to hire a boat from Potobi Boats and Dodgy Don? So it's after 2 hours. So it's that answer there. The Lowinger family will be hiring a boat for 5 hours, and Miss Lowinger's husband insists they should go with Dodgy Don. Provide evidence to suggest that they should, in fact, go with Potobi Boats instead of Dodgy Don. So work out, so this is Potobi, is 15 times 5 hours plus 10. So 15 times 5. So it's 75 plus 10 is $85. And Don is 20 times 5 equals 100. So should go with Potobi Boats, as Don is $15 more expensive. Bit dodgy now. Okay, the last question was difficult. If A is the number that with 100 digits in it, and B is this number with 50 digits, all 9, how many digits are 1 in the number A take away B? So the way I like to do these ones is not write up 100 digits and 50, but actually write up 10 ones. So that's 5, 6, 7, 8, 9, 10, and 5 nines. So 9, 9, 9, 9, 9. And this will give us an idea how this is going to behave. So 1 take away 9 can't do, so I'm going to cross out that and write 1 there. 11 take away 9 is 2. 0 take 9 can't do, that's 0, carry 1. 10 take away 9 is 1. 0 can't do, 0, 1, 10 take away 9 is 1. Can't do, 0 take away 9 is 1. Borrow, 10 take away 9 is 1. 0, 1, 1, 1, 1. Okay, so this one here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10 digits long. How many digits are 1? It's going to be 10 take away 2 that are going to be non-1 digits, i.e. this one's going to be a 0, this one's going to be the 2. Now, the exact same thing is going to happen if I use 100 digits and 50 digits, except what it's going to do is produce a 100-digit answer, of which this one here at the 50th digit mark will be a 0, so take away this one, and the first one will also be a 2, so take away 1. The answer is going to be 98. Tough problem.